So this is the one unit where again it's going to tell you on the exam, do not round. Okay, do not round in this unit. Let somebody knock. Do not round in this unit. The exam. Oh, I should probably talk about the exam format. Okay. The nice thing about the exam is we don't mix it all up on you. It's one unit at a time. So the exam will, in any order, I don't know which order they're going to have the units, but it's going to be vehicle finance. It's going to be like a bunch of questions on vehicle finance. And it's going to be precision measurement. And there's going to be only questions pertaining to this unit. And it's going to say do not round in this unit. So, and I'll remind you that morning when that happens. We started with accuracy. And I just quickly want to, accuracy refers to how close, right, a measurement is to its target value. That's what accuracy is. So think of my desk here, right? We know that this desk has a certain width. It's 3 feet, by the way. We know it's 3 feet. But it could be that you grab a measuring device and you measure it and it's off by like 1/16 of an inch. Right? So this one is actually pretty close to what it should be. But that's what accuracy is. We refer to that. And accuracy can be affected by various reasons. Okay, so for example, if you measure the width of this, and you look at what I'm going to do now. I'm going to bend this down. Right? It's supposed to be straight, but maybe you're bending this down, or maybe you're measuring a little bit on a slant. That affects it, right? So it's like operator error, like it's my mistake. Sometimes it could be damaged, like the actual device could be damaged. But this tab here could be loose, like this tab. For example, this one is already a beaten one that I've used for a while. Look at the play there. That is about 1/16 of an inch right there. Right? So sometimes this actually affects your accuracy as well. So to be accurate, you must use anybody? Standard unit. Standard unit is the ones you know. Centimeters, meters, millimeters, ounces, right? Anything like that, pounds. Anything that you go anywhere, or stones. Did you know that in England they use stones for your weight? Yeah, that's still a measurement. That's actually a unit. But you can go anywhere in the world and say, I walked 5 kilometers. Everybody knows how far that is. But if you went anywhere in the world, you said, I went and walked, 300 spans. What's a span? This is a span, right? It's like, if I measure that with my span and then you measure it with your span, we're going to have different, right? We're going to end up in different camps.
Good afternoon. Excuse me.
I don't think we have any grade 11s. If you are grade 11, just wait. We'll send you later, okay? It's fine. We just don't want everybody bunching up. And use an appropriate scale. That's also important, that you use an appropriate scale. So these two must be there for you to be able to say something is accurate. So don't use kilometers to measure the width of this book, right? That'd be ridiculous. Okay. Would you use kilograms if you're trying to put a little bit of sugar in your batter? Would you use kilograms? No. Teaspoons, things like that. Okay. Accuracy can also be affected by, I right now don't know what's supposed to go in there. Improper, something like that, yeah. Improper or careless use. So if you don't use it properly, or a damaged or faulty measuring device. So these, by the way, guys, all of these things on this page can, if they're not happening, then your measurement could be off. You could be off and it could be inaccurate. If you don't use it properly, if it's damaged, if you don't use a standard unit, or if you don't use an appropriate scale. Oh, I missed something, sorry. if you claim to have measured something accurately, someone should be able to repeat the process and get the same value. That is why we want to use a standard measurement. Okay. Okay. I'm not going to talk more about the rest. The rest, you've got to watch the video if you want to do fine. And even those questions that I've asked you, I'm not going to do all of them. I'm just going to do F maybe here. If use a tablespoon to measure the amount of sugar required for a cake, is this accurate? Is a tablespoon a standard unit? Unit is standard, and in fact. So that it fits that category. Is it an appropriate scale for sugar? Yeah. The scale is appropriate. Check. Therefore, it is accurate. I'm hearing things. Okay, so that would be an example, and if you watch the video, I do a bunch on 3, kind of going over that. Okay, so this is where where we ended up. Precision and uncertainty. This is what I'm going to talk about today. And I don't think, I honestly think this should be like a slam dunk. Every time this happens on the exam, I want you to nail precision and uncertainty. Okay? Before I dive in, okay, I need you to know that if you have a number, let's say 2.9 meters, okay, you can be more specific than that. You could say 2.90 meters, right? Like this one is actually allows us to be more precise because it's got a smaller decimal, right? If it's 2.900 meters, we know that, oh, this device can be even more precise than this one. So the more decimal places you have, the better. That this is the most precise measurement that you could possibly get. Okay. And I know you don't think of it very often, but I have 2 scales here. I'm going to show you. I'm going to try to get you to think about this topic because I know it's this is a little abstract, to be honest, right? Guess which unit we didn't teach during COVID? Because they all told us like you can scrap some units. This is the one. Okay, we didn't. We decided let's just not do precision measurement. So I'm going to turn this on. Can you see that? I hope you can. Yeah, it does. Okay, so I have right, you use vending machines. Did you know that it weighs your coins? Did you know that that's how it knows that it's a toonie? Right? So in this case, a toonie is what? 7 grams. I don't know if you can see that. If I move, but there's a 7 there, right? Oops, 7. If I were to use a different scale, oh, it went to 6. Look at that. 6, 7. I didn't do this. It was not planned. It just happened. Why is it doing that? I know it's not funny when a teacher does it. I know. It just happened. Why is it doing the 6 to 7? Why do you think? What do you think this coin probably measures? Like if you could think about, could it be that this coin measures 6.5, 6.6, and that it rounds it? Like it doesn't know. Like if it's 6.4, what do you do with 6.4? This scale can't do point, right? It can just do a whole gram at a time. So it will go 6. But maybe if it's just in between, it might go 7. It'll round it up or down. So this scale is not very accurate, in my opinion. You could go smaller than that. Let's see what this one says. This one is harder to see normally when I put it on there. I don't think you can see it, can you? Let me see, I'll try something. No. It might not work. Come on. You see it there? This scale says 8 grams. So what's going on, right? So every scale has a slight issue with precision. Like, you may never think of it. You go on the scale when you weigh yourself, you just take that number, you walk off, right? But if you had 10 different scales side by side, you would probably get a slightly different measurement, okay? And so that's one thing I want you to be keeping in mind. Another one is this. I don't know, do you know what this is? A multimeter or a voltmeter, right? To measure how much voltage or the current in a battery. So I've got this battery here. It's supposed to be 9 volts, right? That's what what's supposed to be when it's brand new. Let's see what it tells us. 7.37, because it's an old battery. 'Cause that's when things won't work anymore. If this had been somewhere in your remote or something like that, it would probably stop working accurately, but it still gives us that it's 7.37. Okay. Is it possible that this is 7.374? Something past that 7? Is it possible? It is. But this thing cannot tell us. Like, it's not that precise. It stops after 2 decimals. So there's a certain level of uncertainty that we need to account for. Okay? So let's dive in. I have more down the road that I will show you. I'm trying to bring stuff in to make it a bit more applicable to what you're going to learn. Okay, so here we go. Bring that up. Up to speed there. So precision refers to the smallest, write this down, the smallest increment on a measuring device. I will actually say this, put this on your study sheet. They ask, the province asks in some way, multiple choice, something, they're like, hey, what is precision? It's the smallest increment on a measuring device. Another way of saying this is that precision is the smallest amount by which a measuring device can go up or down by. That's another way of looking at it. Every measuring device, right, no matter how precise, will have a limitation. Precision essentially states what the limitation is. So the limitation is also, and precision essentially states what that limitation is. Okay. Uncertainty, that's the other big topic. I'm going to use a different color for that one, but they are very much related. Okay. You need precision to come up with your uncertainty. Uncertainty here, it is basically due to the fact that every measuring device has a limitation, there's always some uncertainty. All measurements have the potential to be off, okay? Regardless of the precision of the measuring device. At some point, the device rounds up or down. This is called the margin of error. That's another name for uncertainty. And here's the formula. Okay, have this on your study sheet no matter what. What is uncertainty? What do we do to find the uncertainty? We take the precision and we slice it in half. And it's usually stated with a plus or minus, because we could be over or under by a certain amount. This is also important. Okay? So here's how we do this mathematically. This is about the only math that you'll have to do today. Okay? You're expected to state the precision from a picture or diagram, from actual measurement, and if you are given words. So either one, like any of these three I give you, you're supposed to state the precision and the uncertainty. So let's do that here. The precision for this particular container, what is the smallest from marking to marking that I'm going up by? 10. It's very easy, right? This is just 10 milliliters. And put down that there's a 10 milliliter gap between markings, okay? I will write this down. Between markings. Okay, so let's, what's the uncertainty therefore? Uncertainty is your precision divided in half. So that is what? Plus or minus 5 milliliters. So the precision of this device is 10, therefore the uncertainty we're assuming is 5, plus or minus. Okay. All right, next. Actual measurement. Watch this part. You look at your decimal, we focus on that very last digit, the last decimal. So we say that this particular device that was used to measure this piece has a precision of, watch this, 0.01 centimeter. Say what? Isn't it 7, Mr. Erickson? You said it's right there. This is what tells us what the precision is of that device. It tells us that when you measure, whatever you use to measure this can go up by 0.01 centimeter at a time, okay? It's the smallest increment, like how much you can go up by. That's what you just found, okay? What's the uncertainty of that? 0.01 divided by 2, what is that? Use your calculator if you're not sure. 0.005, yeah, that's right. You're going to see a pattern, okay? It's plus or minus 0.005 centimeters, okay? I want to explain this one more time because sometimes students are like, what are you talking about? Can you write that number down here again? I want you to imagine that this is what, let's say this is a digital screen that, right, let's say we use our iPhone to measure, right, that has that capability, and this is what it shows. But it could be that if this piece was a little bit longer, what would it show on our screen? Like, what's the smallest amount we can go up by? What would the next amount be? 28, correct? 27, 28. That's about the smallest you could increase. What about on the way down? This would be 55.26. Okay? And guess what? How much do we go up from one to the other? 0.01. Got it? That's essentially what we're doing here. We're figuring out what can this device go up by? What's the smallest amount? This is the precision, okay? Words is the easiest one in my opinion because it just flat out gives it away. Ruler that is marked in half-inch increments. The only thing is here, fractions are sometimes the thing, right? So half-inch increments, so you can say precision is half an inch. Or if you really don't like fractions, you just turn that, whatever the fraction is, go 1 divided by 2 in this case, and you have that as your precision. What would be the uncertainty? What's half of half? 0.25. So you can just literally say 0.5 divided by 2, that's 0.25. Yes. I wanted to put a dollar sign in front, don't do that. Plus or minus. To be honest, the plus or minus is optional if it's just the uncertainty that you're stating, but I just want to go with it. What's a quarter as a fraction? Yeah, 1/4. So if you notice that, you know, it's a good thing to realize, okay, yeah, you can say a quarter, you can say this, either one is fine, okay? They don't make you do one over the other. So we did our precision, was just given away basically, and then the uncertainty from my precision, okay? All right, let's go over to page 6. I want you to try, I'll do one more because this one is a bit trickier here. I do this every year, right? So for me, it's like, obviously, but you guys haven't seen this before. So let's try this one more time. I want the precision and the uncertainty here. What is the precision here? Don't look at the numbers, look at the markings. You said 50? Yeah, because to go from here to here is 50, right? Because that's the only way. The only way to go from 100 to here would be 150, and another 50 would be 200, right? So essentially, 50 is the precision here. Let me give you a formula for this. This works every time. You go high number minus a low number, and you divide it by the number of gaps. If you're not sure and you would like a formula, I would add this to my study sheet. And let's use that. What's the high number in this case? You pick any two. There's only two numbers, right? But there could be more. You pick any two you would like. The biggest number is our high. And the lowest number, the smallest, is our low in this case. So follow this formula. High minus low, but this is the kicker. You got to do that first. You got to do the subtracting first before you divide. How many gaps are there between the two numbers that we've picked? You start with the low and then you count 1, 2, right? 2 gaps. I'm just making sure you understand, right? Like, please don't count 1, 2, 3, that's wrong. Once you start making a step forward, that's when you count, right? Until you get there. So this is 50 over 2. So precision, sorry. What are you doing, Mr. Jackson? Are you okay? 100 divided by 2 is 50. So my precision is 50 here. What's my uncertainty? What's half of 50? I think this one you should be able to handle. 25, right? So don't think, oh, we always divide by 2 to get precision. No, it just happened to be that case in this if you use that formula. So here's your precision. Here's your uncertainty. Okay, for that picture. Pictures are quite popular on the exam, I will say that. What about 6 feet 2 inches? What's the smallest increment if I look at this? What's the smallest I can go up or down by? 1 inch at a time, right? So it's 1 inch. Uncertainty is plus or minus 1/2 of an inch or plus or minus 0.5 of an inch. One thing you need to make sure is units everywhere. I can't try again. This is as best as it gets. Okay. Measuring tape with markings of 1/4. That's 1/4 of an inch. It's the precision because they tell you what the markings are. Just turn that into a decimal. Right? Precision of 1/4 of an inch as a fraction. This as a decimal. Uncertainty, therefore, is plus or minus Zero, I'm gonna use the decimal. I feel like that's the one most of us are gonna use. And so you take 0.25, and here's where no rounding comes in, okay? If you're sleeping, make sure you don't for this one. We use all 3 decimals here. What do you think this is? This would be as a fraction. What's half of a quarter? Like if you slice something in half, you'd actually double the denominator, so it's 1/8, or it's 1/8. Okay. If you like decimals, stick with decimals. You'll be fine. However, they might start you off with fractions. You turn it into a decimal, then work with it. Okay. So precision here, uncertainty there. Okay. I'm going to ask you to try that one before I move on. I just want to make sure you first, you at least give it a try. See, do I understand this, or do I need more explanations? Okay. So try this one right here. Precision and uncertainty for this. Okay. Give it a try. Write something down. There's lots of space. Okay. I'll correct it. It doesn't matter. Like I like you discussing it. So when there's a picture, I use this one, high minus low divided by gaps. That's a fail-safe, very little guessing that you have to do there. So where do you want to put the high and the low? Like there's a lot of numbers, correct? Pick any 2 numbers. I'm going to pick this one. That's going to be my high, the 30, and the 20 is going to be my low number. Okay? So I'm going to go 30 minus 20. Make sure you put that in brackets. That needs to happen first. You might get the same answer as me. So you're not wrong yet. Which ones did you pick? Which ones did you pick? The 60? 60 and 10, that would work. You just have to have more counting. Yeah. I'm getting there to the dots. I'll tell you what, because what we're trying to figure out is how much am I going up from dot to dot, from marking to marking. Is it 1? Okay, I'm not even thinking. I'm just trying to use this formula right now. But let's count from the low. You go 1, 2, 3, 4, 5, right? 5 gaps. So this is 5. Yeah, it's 2. So 30 minus 20 is 10. Divided by 5 is 2 what? Minutes, right? It says it right there that this is in minutes. These are all pictures that I took at home, by the way. All of these things that you're going to see, that's why it looks so cheesy, right? I'm trying to like get rid of everything else. 2 minutes. Christian, can I ask, what did you get? Did you get 2 as well? No? Okay. Let's check if 2 works. Go ahead. Okay. Well, we're going to try your method. You're daring me to try yours. 10 and 60, that's what you used, right? Okay. 60 minus 10, right? How many gaps are there? Oof. So there's 1, 2, 3, 4, 5, right? 5, 10, 15, 20, 25, right? 25 gaps. So that's 50 divided by 25. What is that? Yes. Oh, I locked you out. 2 minutes. So regardless of how you did it, you get 2 if you're careful. Okay, hold on. You think you're done. Check. Guys. So go up by 2. 22, 24, 26, 28, 30, right? Like if you go up by 2s, you actually get to 30 from one to the other. That's to verify. Okay, we got our precision, which is 2, right? What's our uncertainty? 2 divided by 2, right? Plus or minus 1 minute. Yeah. So the standard, so if you were to tell me, if you were to set this timer to, let's say, 30 minutes, right, and let it go, we would say it's 30 plus or minus 1. It could be 31 or 29 minutes if you let it go. These timers are notoriously off. I don't know if you've ever tried it. Like these little eggs that you do, like if you actually time it with your phone, you're off by half a minute easy, which is not a big deal if you're boiling eggs, right? Like it doesn't matter. But I'm just saying, these timers are off. Does that make sense, guys? The precision and the uncertainty? Maybe you need more practice, that's fine. Let's go over to the actual measurement. How many decimal places is my answer gonna have, guys? 1, 2, 3 decimal places. So you fill in zeros everywhere else, and where that last decimal lies, that's where you put the 1 in to tell everyone that the device that was used to measure that is this precise. It can go up by, like you wouldn't even notice if I added 0.001 millimeter to this desk. You wouldn't even notice that. But that's how precise this thing is. If you're in automotive, if you work in the cars, right, the cylinders, right, when you're redoing your cylinders, that's when you start using this kind of stuff, right? Or the gap between spark plugs, the spark plug gap. You know what I'm talking about? Some of you are like, what are you talking about, Mr. Dixon? If you look at a spark plug, it's literally what causes the spark in your engine, right? There's a little, I don't know, guys, I'm terrible at art, but there's literally like this little metal piece and this piece, there's a spark that happens between, and that's what causes the explosions in your engine, literally, like thousands. And so if this gap is too big, then it's not going to give you spark. If it's too close, it might not be enough to generate the spark either, right? So this gap can be measured with instruments that are really, really precise. Like, anybody know what a feeler gauge is? Anybody? If anybody nods, I know you're in automotive. No? Okay. I will show you what a feeler gauge is one of these days. Okay, hold on. What's my uncertainty now? You divide that in half. This is the pattern. You're going to add a 0 to it and then 5. This is my precision. This is my uncertainty. So we're looking very, very precise. What about this one? Cup marked in 125 milliliter increments. That means that your precision is that. It's the markings. And the uncertainty is half of that. What's half of 125? 62.5 milliliters. Use a calculator. You don't have to do it, right? Like you don't have to use mental math there. Okay, let's keep going here. I'm going to give you a little bit of time to familiarize yourselves with this. So for the next, I don't know, gazillion pages, 14. It goes all the way to 14. And it seems like a lot, but there's lots of bigger images on there, right? So I want you to, for every single one, figure out the precision and figure out the uncertainty and so forth, okay? Do one page first. Okay? I want you to all work on this right now. Face forward. Some of you are still not sure, well, how do I do the high and low thing? I'll say this. Listen carefully to this. You want to figure out what is the increment from marking to marking, not number to number. So some students ignore the markings. They're like, oh, it's 5, right? In this case, it is 5 because every number has a marking next to it. In that case, yes. Okay. So the precision here is 5 milliliters, and some of you use the formula. If you go high and low, if you pick these two as your high and your low, you would go 15 minus 5, that's 10. And then you would count the gaps, right? There's 2 gaps, 2 steps. So that's still, if you go 10 divided by 2, that's still 5. Yeah.
But there's like a smaller increment between 5 and 10. Let's say, would that be 2.5?
Oh, this here? Are you talking about this? I did a bad job at getting rid of that. But you have a very good point, okay? So did you go 2.5?
Yeah.
Leave it. Because if that's how you read it, then that's what it is actually. If you note, technically there's this part is technically around the corner here. So technically that doesn't belong in here. But I will say leave it because that's technically correct. If you had, watch this guys. Crisanto, pay attention. What if just for this, if I had markings in between, right? This is no longer 5 because watch, you go, this would be then technically 10, 15, it just doesn't work, right? So then you have to go high minus low, let's say, you go 10 minus 5, that's 5, divided by 2, in that case it would be 2.5, right? So I would say put these markings in between for you so that when you look at this example, it makes sense that it's 2.5. Got it? Okay, this one, every marking has a number next to it, and you can tell it's going up by 1. So it's 1 teaspoon. So it's 5 divided by 2, plus or minus 2.5. This is plus or minus 0.5 of a teaspoon. I'm not even gonna, I told you here, omit the dots, like don't worry about the dots, just think of the numbers, focus on the numbers. So what are we going up by here, every number? We're going up by 50, right? So here the precision is 50 degrees Fahrenheit. Uncertainty is plus or minus 25 degrees Fahrenheit because we split it in half. Okay? Let's go to page 9. Again, lots of things, lots of markings. I'm going to pick this as my low and this is my high number here. So I'm going to go 700 minus 600. It's smarter to pick close by, okay? How many gaps are there? 1, 2, 3, 4. There's 4 gaps. So that's 100 divided by 4. That's 25. And we're in degrees Fahrenheit. It says it up here in case you missed it. It's also faintly there. Uncertainty, you go 25 divided by 2. That gives you plus or minus 12.5 degrees Fahrenheit. Okay. Next, you've got the temperature there. This one is a little trickier. Celsius is the outside, Fahrenheit is inside. I asked you to do both, but if you did one at least, that gets you somewhere. Let's make this the high and this the low, let's say. So for precision, I would go 50 minus 40, high minus low, divided by, count how many gaps there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 gaps in between. 10 divided by 10, that is just 1 degree Celsius. Uncertainty, therefore, is plus or minus 0.5 degrees Celsius. Did anybody do Fahrenheit? Fahrenheit, if you go with Fahrenheit, 120 and 100, I'm going to make a line here. This is Celsius, And I'm going to do Fahrenheit here. Precision, if you pick these two numbers, is 120 minus 100 divided by, how many gaps are there? Anybody count? I'm going to tell you already it's 10 again. 10 gaps between those two numbers. That is 20 divided by 10, which is 2 degrees Fahrenheit. So this thing goes up by 2 degrees Fahrenheit every time if you want to talk Fahrenheit, or 1 degree Celsius if you want to go Celsius. Uncertainty is 2 divided by 2, so it'll be plus or minus 1 degree Fahrenheit is the uncertainty in this case. So we've got Celsius and Fahrenheit back to back. This one is a little controversial. Can I just ask you to add something to this? Ignore the arms, okay? Or the dials. Ignore that. What is the smallest increment here? It's 1 hour. And uncertainty is plus or minus half an hour. Okay? So when it's a clock like that, the precision is just 1, and the uncertainty is 0.5. Let's do some numbers here. What about that? What's the precision of this? 102 Fahrenheit. It lies in the smallest number, the smallest unit, which is what? 1 Fahrenheit. And the uncertainty, therefore, is plus or minus 0.5 degrees Fahrenheit. Okay, so when it's a whole number, it's in the ones. Right? This thing cannot show you 102.5 or 0.1. It can only show you 102, 101, or 103, right? It only goes up by 1 full degree. That's the precision of this. That's the limitation of this device. Okay. One more. What's the precision here? If it's 0.0, 0 point, it's right there. This thing can go up by the smallest increment of 0.1 kg. Okay? Uncertainty is half of that. To get from here to here, I just divided it in half. Okay. So don't give me 0 if you get a 0 number. The precision is still here. It goes up by 0.1.
Excuse the interruption, grade 11, last name.
One more. Just listen to this part. Rulers, okay? Imperial. Imperial is feet and inches. What would be my precision of this particular ruler if I asked you to do that? You go, listen to this part, you go from 1 inch to the other, and you count how many gaps there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 is the smallest increment. So this will be what? 1/16 of an inch. I don't like fractions, Mr. Dirksen. You're in luck. You go 1 divided by 16. Do not round. It is a small amount that you go up from one measure, from one marking to the other. That's how you do rulers, okay? Okay, I'm going to leave it there. I still encourage you to finish all the way to 14.